Today's question is network delay time. So in this question, they will give us a directed graph along with the time to reach from source to destination. Then we will be given with a k. Using that, we have to start from k and we have to try to reach all the nodes in the graph. So we have to find out what will be the minimum time taken to reach cover all the nodes. If we are not able to cover all the nodes, we have to return -1. So let's get into one example and see how we can solve this. To solve this, I have taken one example, a directed graph along with the weights to reach the node from source to destination. So we can solve this in 3 different methods. So we'll see in all the methods how we can solve it. So let's first talk about DFS method. Then we will look into other methods. So in DFS method, what we will do, they have given the source node as k. From we have to start from k and we have to try to reach every node. So in DFS, it will be a recursive solution. So we will take a call stack. So in the call stack, first we will be calling the source node along with the time taken to reach the source node. Since the source node is the starting node, we can reach the source node with 0 time. So we will use this time and we will call the DFS program. So here we use a visiting array for DFS or BFS. So in this visiting array, we will initialize all the nodes to infinity, time taken to reach all the nodes to infinity. And here in the question they have said there will be nodes starting from 1 to n. So we should exclude the 0th node. So I have excluded the 0th node and I have initialized the 0th node with some minimum time so that it will not come into our calculation. And rest all nodes I have initialized with infinity, so that we will be able to see at the end we will be able to know whether we were able to reach the node or not, or we'll be trying to minimize the time taken to reach the node. So we have initialized it with maximum value. So first, when we called our program using the given source and the time taken to reach it, then we will record this value. And also before calling only, we would have recorded this value in our source node. So this 2 is here, and we would record this with our minimum value, which is 0. Okay, now once we call this program, we will check its all the adjacent elements. We will check its adjacent element, which is 1. And we will see whether current time plus this time taken to reach node 1 from 2, whether it is smaller than the already existing time. So since infinity is the already existing time taken to reach 1 is greater than the current time taken to reach the node from 2, which is 0 plus 3. So we will update this value in our visited array, and we will call the 1. So we will update the value in the visited array as 3. Time taken to reach 1 is 3. Now we will remove this and we will call this with 3 comma 1. Okay, now we will from 1 we will try to call its child is 3. So from 1 to reach 3, what will be the time? Already to reach 1 we spent 3 time. From here to reach 3 it will be 5. So 5 is lesser than the infinity, so we will update our value to 5. And we will start calling the node 3 as a parent with the time taken to reach node 3 was 5. So this way we reached till 3, and in this DFS iteration, DFS depth, now we will from 3, is there any other path? We can reach 1. From 3 we can reach again 1, and we will see from 3 to reach 1 what is the time taken. From already to reach 3 we spent 5, and from 3 to reach 1 we have to spend another 3 time. So here the total time taken to reach 1 will become 8, and we will check whether 8 is lesser than the current thing. So already we were able to reach 1 using 3 time, but now we have to spend 8 time to reach 1, which is more than what we already have. So we will not consider this, and we will move forward. And 3 does not have any more childs. Then we are done with the tree's depth. So we will pop the value from the loop, from the means we return from the calling stack. So our calling stack is now here. In 3, let us so we were in 3, node 3, we came out of the calling stack. Now we are in node 1. We will see from node 1 we finished calling this. Is there any other nodes left? No, there are no other nodes left in 1. So we will pop this calling stack also, means we will return from this calling stack. Now we are at node 2. From node 2 we did our reached our child 1, but we did not still reach our child 3. So we will try to reach our child 3. To reach 2 we spent 0 time. From 2 to reach 3 we have to spend 1 more time. So 0 plus 1 is 1. 1 is less than what we already have in our visited. So we will erase this visited, and we will store 1 to reach 3. Okay, reach 3. From 3 we will now we will call our function with time to reach 3 is 1, and the source node is 3. So our calling stack looks like this. From 3, are we able to reach any other node? So yeah, we are able to reach 1. Let us see. To reach 3 itself we spent 1 time. From 3 to reach 1 we should spend additional 3 time. So it will be total 4 times we have to spend to reach 3. So reach 1 from 3. So we already were able to reach 1 in a lesser time, so we will not consider that option. So now 3 does not have any more child to traverse. So now we will pop the stack, means we will return from the 3 call. Now we are left with the 2's call. 2 also we already finished both the child's calls. Now we will return from the main calling. Now we are done with our DFS operation. Now whatever we find it minimum here, we will return that as our result. So here the minimum is maximum. Here the maximum is 3. So our result will be max of visited. Okay, so the result is 3. Okay. So this is how we were able to achieve from DFS. Let us try to understand how we can solve using BFS. So BFS is also a similar approach. Here we were using call stacks, but BFS will be straightforward. So BFS I will explain in the next video or in the implementation itself. Let's get into the code for DFS. So let me get into the code. I'll be using Python. Here for DFS we need a visiting array, right? So in the visiting array we will initialize all the elements to infinity. Okay. they have given us n, so we will remember we have to store from 1 to n instead of 0 to n, so I am using +1, and I will visit my 0th element and I will say it is negative infinity because we don't need the 0th node. So that this way we will have 1 to this populated with infinity, and the 0th index will be in -infinity, so that it will not affect our result. So we have now they have given us the input in form of a list. In this list we have like this source, destination, and time taken to travel from source to destination. So what we have to construct a adjacency list so that we will be able to process easily. So let me take adjacency list as a dictionary. Let's go over all the things in this times they have given us, where this contains source, destination, and a time taken to travel. Okay, now let me check whether we already have the source existing in this one. If source is not in adjacency, then we will add the source. We'll add the source like this, list for a source, and we will append the destination. So we will put time in the starting, and so that it will be useful for sorting in the future programs. Time for the sorting and destination here. Okay, now we have filled up our adjacency list. Now let us try to write the DFS function. So inside DFS we will again we will take the time till now in the front, and we'll take our source here. Now we will check if our source is present in adjacency list, then only we will be able to move forward. If the source is present in the adjacency list, then we will iterate over all the time difference we need to reach the child, and what is the child destination from that source in the adjacency of source. So whatever we stored here, time taken and the destination, we'll be retrieving it, and one by one after retrieving it we will check whether already in visited array whatever we have for the destination, whether that is greater than whatever we are going to reach, the current time taken to reach the source, and from source to reach the destination what will be the time taken. So we will check whether that time taken is lesser than what we already have reached from using for D what we already have. If that is lesser than, then we will update that value in our visited, and we will call it we will call the DFS function again for the destination with this time taken value. Okay, like this we will be able to traverse over all the things using DFS. Now in our main program what we will do, we will call our DFS with whatever source they gave us, that is k, and time taken to reach the k. Before that we will update our visited array for k, which is time taken was 0, and we will return our result. Result is our maximum element in our visited array. We will return -1 if there are any element which was unreachable, that is if the result is equal to infinity, then we have to return -1. else we can return our result directly. So let me try to run this. If there are any bugs, we can solve it. Okay, hey guys, there was one small mistake here. So I had put minus infinity instead of infinity, and here I have put minus. Here the minus infinity is correct. Remember, so here first one we have to keep it minus infinity, and others we have to keep it infinity. Right. So let's try to run it now. Okay, it works fine. Let me try to submit it now. Works fine, but the time is very high. So what we can do to optimize is we have to make what is our goal is to we have to minimize the time taken to reach, right? So what we can do in this for all the keys in the adjacency list, for keys in J, we can sort the keys. Adjacency, whatever list we have, we can, for each key we can sort it. So after sorting, let us see whether it runs. If it runs, let us submit and check is there any improvements. Okay, see the drastic improvement here. After sorting, it works fine after sorting the adjacency list, so that it will pick the minimum first itself. So thanks for watching. I will upload the video for BFS approach now in the next video. Thank you.